Good evening. I'm Stacy Fitzpatrick, and welcome to another episode of Science, Friend or Foe. This evening we have the special privilege of interviewing Professor Ben Dover, a Nobel Prize-winning scientist who's going to teach us tonight about acid. Not the illegal kind, the sciencey kind. In a few moments, after words from our sponsors, we'll begin the interview.
Have you ever wanted your lemons to be more acidic? More lemon-scented? Well, I, Larry Big Bucks, have the answer for you. Larry approved lemons. These lemons are guaranteed, not 10%, 150% guaranteed to make your life better. Plus, they're more acidic, about 50% more acidic, and they smell just like lemons should. Alright, I'm Larry Big Bucks. Buy your lemons today, only $19.99 a crate. Hey, didn't notice you there. Well, I'm here to talk about Market Pantry baking soda. You see, people who don't have this, they look like this guy. They look like this clown. You see him? Look at this clown. Yeah, exactly. You don't want to be like him. No, you want to get some baking soda, but Market Pantry, because it's got tons more base in it. It's actually got so much base that it could almost be poisonous, but it's not, because we would never do something like that to you. Because we are a family company who loves people and money and baking soda. And we are very excited about the brand new line of baking soda products that we were going to give to you, the public. I'm Vinny, and I approve this message.
Dr. Dover, I want to thank you again for being here for another episode of Science, Friend or Foe.
Really, it's my pleasure, Stacy. I love the show. It's really great. It does science good.
Well, thank you. Let's talk acid. What is stomach acid?
Well, I'm going to start more with just regular acid, then I'll move down to stomach acid, Stacy. Basically, acids in general are any compound that increases the number of hydronium ions, or H3O+, when they are dissolved in water. They usually have a lower pH level. They usually are things like lemons, or milk, or other acidic things that you may find in your journey through life.
Amazing.
I know. A base is basically any compound that increases the number of hydroxide atoms, or OH-, when they are dissolved in water. They usually have a higher pH level and are things like baking soda.
pH level. What's that?
Well, that's another great question, Stacy. You never stop asking great questions. pH is the measure of the hydronium ion concentration in a solution. It's usually used to describe how acidic or basic a solution is, or the strength of an acid or a base.
That's fascinating. What is a buffer, and what does it do?
Well, a buffer is a compound that can stop the pH level from changing when an acidic or basic compound is added. This works because the two components, conjugate acid and basic compounds, when they are put together at equal amounts, when equal amounts of each are basically put together, they form a buffer which is able to neutralize small amounts of other acids or bases, but not any large amounts, because if it tried to, neutralize a larger amount, then it would, kind of deteriorate.
Yeah, just wouldn't work.
Gone.
Wow.
Yeah.
Wow. Exciting.
It is.
You mentioned the term neutralize. Can you explain that for our viewers?
Well, when something is neutralized, it becomes neutral by something counterbalancing the effect of something else, thus neutralizing it, as I said before.
Great. Well,
Isn't it?
what kind of acid is in our stomach, and what is its strength?
I'm about to use some big words here, Stacy, so just watch out.
I'm ready.
It's a hydrochloric acid and has a pH level of 1 to 3 when your stomach is empty. But when you have food in your stomach, the pH level can go up to 4 or 5.
Wow.
The pH of the small intestine is about 8. But the problem is that if you were to drink this kind of acid, you'd probably die. It's usually a dark green color. If you were to taste it, it tastes something like some vitamin drink or something. It really wouldn't taste good, and it'd probably be eating away at your tongue.
That's great. Well, this has been absolutely fascinating. But I've got to ask the question that's on everybody's mind. If our stomach acid is so strong, why isn't it burning through the lining of our stomach and spilling all over our bodies?
Well, that's a funny way of putting it, Stacy. But, you know, those usually who don't know much about science would put it like that. Basically, the cells in our stomach secrete a mucus and bicarbonate base. And when this base is added to this acid in our stomach, they form a buffer. And, of course, the lining, all of our stomach, is coated in this mucus and bicarbonate thing, this base. And when they're come together, they form a buffer and are actually, fascinatingly enough, able to neutralize the acid in our stomach enough so that it wouldn't eat through our stomach. Isn't that fascinating, Stacy?
Well, not only fascinating, it sounds pretty gross.
Well, that's why we don't have clear bodies.
Excellent point. Well, thank you so much, Dr. Dover. I feel like we've all learned so much. I'm glad we didn't waste time watching a movie or something like that.
Science is not a waste of time. I see what you were implying here, Stacy. I'm a little offended, honestly.
Well, get over it. Thank you so much. Until tomorrow, I'm Stacy Fitzpatrick.
And I am a Nobel Prize winner.
That's what he keeps telling us.
Yep. And a scientist.